Currently, Electricity North West are involved in two main streams of research into transformers. The first is looking into the degradation of the oil and ways in which we can regenerate that oil to increase the lifespan of the transformer. The second is the monitoring of tap changes to allow for an earlier detection of faults and failure modes, allowing for a more targeted maintenance regime. Again, looking to prolong life and ensure that we target the units that need it rather than a traditional age-based approach where transformers would get maintained at a certain interval whether they needed it or not. So the oil regeneration process that Electricity North West are investigating started life towards the end of the transformer life, where we attached a mobile unit to the transformer, circulated the oil through it using various filters to remove the impurities, and then circulated it back into the transformer. We've since developed that process such to a two-stage process now, where we do an initial clean of the oil, and then we found that by heating the unit above 65 degrees, that allows the impurities that are absorbed into the papers that insulate the transformer core to be released. And then we do a second cleaning process which removes those impurities as well. What we found on the initial process was that although we got a good result for short term, as the unit was put back into use, those impurities came out of the core and the oil quality degenerated again. So by doing this two-stage process, it produces a much longer lasting effect and gives us a better impact on transformer life. One of the parts of the transformer that's most prone to failure is the tap changer, because that's the part at which you have the mechanical movement. So generally that's maintained on a time-based period. What we're trying to do by using the tap changer monitoring equipment is by affixing acoustic sensors to various locations around that part of the transformer, and by monitoring the sounds generated during each operation and feeding that through an algorithm which can detect changes in those noises, is to pick up potential sources of failure before they develop into a problem. So traditionally, if a tap changer degenerated to the point where it was failed, the first we'd know about it, if it wasn't picked up on a time-based maintenance, would be when you had alarms due to control. That would mean switching out the unit, putting customers at risk for a significant period whilst we resourced specialist teams to come and carry out a repair. By using the tap changer monitoring, the plan is that we detect that in a sufficiently timely fashion that we can arrange the repair with the transformer still in service, so you reduce that period of risk to the customers, and equally we're not using those resources to go around and maintain units where there's still significant life in the tap changer before it requires this sort of maintenance.
The primary focus of the dissolved gas analysis and the tap changer monitoring system is to support the research and development of the oil regeneration of a transformer to maximise its life expectancy, while also understanding what this effect of extension of life on the transformer has on the tap changer also. In addition, these systems also provide real-time health indices of the transformer and tap changer they are monitoring within their operating environment. Any changes in environment or deterioration of the transformer or tap changer is picked up immediately and investigated before any potential damage or deterioration caused to the asset. This high level of monitoring on the transformer and tap changer assets will help optimise maintenance procedures and asset replacement strategies going forward within the organisation.